Just weeks after a United States Navy admiral expressed embarrassment at the lack of progress made in the service's development of laser technology, it was announced that the efforts may be further longer than previously reported. Late last year, the U.S. Navy's Arleigh Burke-class guided missile destroyer USS Preble DDG-88 conducted a test of its HELIOS weapons system against an airborne target. The system, the high-energy laser with integrated optical-dazzler and surveillance, HELIOS, is a 60-kilowatt-plus high-energy laser that is being developed by Lockheed Martin to counter fast Inshore Attack Craft, FIAC, and unmanned aerial systems, UAS. One assumes that Admiral Darrell Lane Caudle, head of the United States Fleet Forces Command, should have known about the tests, so his comments at the Surface Navy Association's annual symposium in Washington, D.C., seem a little surprising. Details about the HELIOS are sparse, but a recent report from the Office of the Director, Operational Test and Evaluation, DOTNE, the principal official and advisor to the U.S. Secretary of Defense, shed a bit of light on the laser technology. The Center for Countermeasures, CCM, supported the Navy's demonstration on USS Preble, DDG-88, to verify and validate the functionality, performance, and capability of the HEL, with integrated optical-dazzler and surveillance system against an unmanned aerial vehicle target. CCM collected imagery of the engagements to support the evaluation of system performance, the report stated. A black and white photo taken by CCM showed a bright laser beam fired from the warship at an aerial target. It was one of several tests that took place last year. Lockheed Martin first announced the development of the laser 4 years ago, in January 2021. At the time, it described the weapon more than just a high-energy laser. The HELIOS system's multi-mission capabilities include long-range intelligence, surveillance, reconnaissance, ISR, and counter-UAS-mounted ISR, CISR, Dazzler. The company added, the HELIOS system's deep magazine, low cost per kill, speed of light delivery, and precision response enable it to address fleet needs now, and its mature, scalable architecture supports increased laser power levels to counter additional threats in the future. The Direct Energy Weapon, DEW, has a power output that is more than enough to support 60 U.S. houses, and according to the defense contractor, the scalable laser design architecture spectrally combines multiple kilowatt fiber lasers to attain high beam quality at various power levels. It is reported to have a range of approximately 5 miles, 8 kilometers, while it can be scaled up to deliver 120 kilowatts of power. According to the Defense Post, the laser has a layered defense approach that includes both hard and soft kills of hostile threats. In the former, a target can be destroyed, while the latter simply disrupts the electronic components, at least enough to disable contact with their operators. As previously reported, delivering the energy to the laser weapon is still the greatest issue that needs to be overcome. Conventionally powered warships may not be able to provide the power to sustain such weapons, and it would likely require a nuclear reactor, like the ones on the U.S. Navy's Nimitz-class and Gerald R. Ford-class supercarriers, to deliver the necessary power to stop a fast-moving threat. In addition, during a past test, a 150 kilowatt class DEW required 15 seconds of sustained fire to destroy a relatively slow airborne drone, while a 1 milliwatt, 1,000 kilowatt range weapon is likely needed to engage ballistic or hypersonic missiles, which are hardly likely to remain within range for 15 seconds. Even that might be limited to burning through the side of the fuselage, which would be insufficient to stop the missile altogether. Perhaps that explains Admiral Caudle's comments about the lack of progress. Developing a weapon is just one half of the problem. Powering them is the other half.